Looking for ways to connect with the Unreal Engine community online? From the forums to webinars, live streams, and full-on virtual events, our community of creators is staying active. And we've gathered a list of resources and online activities in a single, handy blog post that will be continually updated with new events. Jump over to the blog to see where to connect with us and the community. For those keeping count, Unreal Engine 425 Preview 5 is now available for download via the Epic Games Launcher and GitHub. Remember, these builds are not intended for production, so make copies of your projects if you're testing out the preview. Try out the latest features, then head over to the 425 Preview forum to let us know what you think. Developed by the studio that made the classic Carmageddon series, Shock Rods possesses many of the qualities you'd expect to find in popular vehicular combat games. However, it actually plays more like an arena shooter with cars. To gain insight into how Stainless Games designed the unique shooter, we interviewed game director Neil Barnden. Read his perspective on what games influenced the project, their game jam development style, and how they empowered the team to create inventive modes and environments. The University of Hertfordshire, one of the top game design schools in the world, consistently sees their graduates securing jobs at major companies like Nintendo and Bentley. One of the driving forces behind this success is the opportunity the program provides to go beyond games and explore other applications of real-time technology. Whether a student or educator, dive in our interview to see how the University of Hertfordshire prepares students by teaching them real-time skills in high demand across an incredible range of industries. On March 29th, Milestone hosted the first ever MotoGP virtual race, in which professional players raced in an esports competition in place of recent canceled events. 10 riders battled during the 6-lap race of Italy's Mugello circuit in the Unreal Engine title, with Alex Marquez claiming the victory. Catch their next race on April 12th. And now over to our top weekly Karma earners. Many thanks to Clockwork Ocean, Everynone, Black Force Dragon, M4G50, Shadow River, Smelnick97, Super Funkstar, Bruno Kexito, K Montoya, and Def CZ. Thank you all so much. Now over to our community spotlights. Game Deck is a single-player cyberpunk RPG in which your experience is affected by decisions rather than combat. As a detective, you'll unearth schemes, save lives, and investigate the extraordinary relationships between virtual worlds and their inhabitants. Congratulations to the team on their successful Kickstarter campaign, and visit GameDeck.com for more information. Inspired by Pixar animated films, Spider is a newly released game set in a stylized world of retro espionage and political intrigue. You play as Agent 8, the most sophisticated miniature robot spider on Earth. The itsy bitsy super spy is equipped with all of the gadgets and gizmos you'll need. Cut through panels, overload terminals, flip switches, and open valves as you scurry about sabotaging the heinous plans of evildoers. Try out this Apple Arcade exclusive today.
We need your help. The world is in serious danger. Our future is in your, hands?
Here we have VR dungeon crawler The Morrigan. Step into a perilous world armed with a torch in one hand, a big axe in the other. Take down your enemies in hand-to-hand combat, harness the power of time, and solve mysterious puzzles as you return to collect a debt from the king. Download The Morrigan on Steam today. That's it for this week. Thanks for tuning in to our news and community spotlight.
Hi everyone, and welcome to Inside Unreal, your weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Victor Broden, and with me today I have a merry bunch of audio programmers and designers. And to start off, I would like to welcome Ethan Geller, senior audio programmer. I've got Dan Reynolds down in the corner, our technical sound designer. I have Phil Pop, another senior audio programmer. Max Hayes, another audio programmer. And last but not least, Mr. Aaron McLaren, our lead audio programmer. It almost looks like we're about to start a choir here.
Oh, I looked the wrong way. I was trying to look this.
Oh no, you got it.
Should all try singing on 3 or something. I don't know.
I gotta
maybe
hand Ethan something.
Oh,
hand.
no.
I get that. I get it. Hand. Today we're going to cover a little bit of what's been happening in 4.2.5, right? Our audio updates. And I think with that said, I'll hand it over to Mr. Aaron.
Cool. My name's Aaron. I'm the lead audio programmer at Epic, and I've done a couple of live streams. I think we do like one every year. So you might have seen me before if you've come here before. Dan and I have done a bunch. So if you're new though to the live stream for audio, or if you don't know much about audio in the Unreal Engine, I just want to give you a brief sort of context to this. So the Unreal Engine features a custom-made native multi-platform audio renderer that is fully featured and has shipped on plenty of games. It is used on all of Epic's games, including Fortnite. I announced the sort of new vision of the new audio engine in 2017 in GDC. So Google the future of audio in Unreal Engine to see sort of the initial sort of like, hey, here's the thing. Well, that was the announcement of the future of audio. Now the future is here. And so this is one of the live streams. We're going to show some of the cool tech that we can now do as a result of a multi-platform audio renderer. So since 2017, we've shipped it on all of our platforms on the Unreal Engine. We've shipped it also on every platform in Fortnite. Fortnite has 7 platforms, so it's now live to all of our millions of players, and that is that means all of the memory and performance and stability work that went into swapping out an older audio engine with a new one underneath players without them noticing. And excitingly, we've, as a result of that, turned on the new audio renderer in 4.24 by default. So if you are using 4.24, you're already using the audio engine unless you've manually gone and reverted back to the old audio engine code. And in 4.25, as a result, we can start moving forward on some exciting features. This live stream is one of the first sort of things we're going to talk about, some of that new tech. Because of GDC getting canceled, a lot of these demos we were working on for our GDC booth that we have at the Expo Center. Every year, the last 4 years, I think, the audio team has been given a sort of dedicated booth, which is very exciting for Epic to give us a little bit of a platform to show off cool audio features. And so because that all got canceled, we wanted to sort of have another venue to talk about a lot of that stuff that we were working on. So that's what we'll talk about later today. And a couple things I wanted to point out also is that there's a lot of people on the stream now. It's not just Dan and I. Ethan it was our first audio programmer hired after myself. How long have you been at Epic now, Ethan? Like
Since
2.5 years?
May, I want to say 2017. So
Yeah. So he was hired, I think, right after the 2017 GDC thing. In fact, I think I was recruiting you at that GDC. I was like, you're at our booth, and I was like, hey, Ethan, you gotta come work with us.
For sure, yeah.
You know, GDC's a big recruiting thing. You know,
if you watch that
oh yeah,
talk,
no.
his is one of the first questions.
Please watch that talk,
Yeah.
but please skip through the first question.
Yeah, he was actually this is great because actually one of the features we're going to talk about is something you worked on that you asked about in 2017. Do you remember that?
Yeah. Oh, I do remember that.
Yeah,
sure.
he was like, hey, so when is it ever going to be able to do X? And I didn't literally understand what you were saying. So if you look at my response, I'm like, what the heck is he talking about?
Yeah.
I had no idea. And I tried to BS an answer. And then we hired you and you're like, hey, so that thing. I was like, oh, wait, you're the one who asked that question. And he's like, oh, yeah, that was me. I was like, well, you do that feature. And so, he's done it and he'll give a little talk about it later today.
Didn't realize the full circle nature.
Yeah, it's a full circle nature. We didn't think about it.
Yeah.
It's the channel agnostic audio rendering.
Yeah, for sure.
Yeah. So we'll talk about that later. I'll in a second. I'll go over the sort of tech we're going to talk about. So Ethan was the first hire after GDC in 2017, and then since then it was about a year since we hired more. A little over a year ago, I'd say November 2018, we hired Rob Gay, who's on our team, from Arena. Actually, I worked with him at ArenaNet, but he went to Amazon, and then from Amazon he came here. And then after that, we started hiring more rapidly. So now we are. So then I'm trying. I got myself in a trap. I had to remember the order at which we hired everybody. Point is that we've hired a lot of people. We have 7 audio programmers on the team. Matt. On the live stream here, we have Phil, who is a friend of mine from graduate school.
Yeah, we go
way back, like 11 years. And Phil, in grad school, was sort of the resident DSP wizard. And I remember we paid you in beer.
Oh yeah, for those
sit
classes.
In whiteboard DSP.
Yeah, every class slowly devolved.
Yes.
It could only last so long.
It was like we'd all be like, Phil, we don't have any money, but look at some six, because beer's better anyways. So we would relax and chat and whiteboard DSP problems. And since graduate school days, Phil went on to do some pretty cool stuff in his career. And then I pulled, not in games, and I was like, hey, Phil, you got to come over and work in games. And so he joined us a little over a year ago now and has done some really cool work. A lot of it's highlighted here. And Max is our most recent audio programmer hire. Actually, no, that's technically not true. Jimmy Smith is our most recent hire, which he's not on the live stream, but I'll mention that. So Max Hayes was our intern from DigiPen. About a year and a couple months ago, you started us as an intern. In fact,
last January.
Yeah, January. In fact, he joined us as an intern like maybe a month, 2 months before GDC. And I remember telling him like, hey, Max, we really don't have time to do a lot of like teaching because we're all crunching on GDC. So I was like, here, just do something cool. Just sit here, point him in a direction, do some cool stuff. And then last year, during GDC, he actually did a feature that we ended up showing on the Tech Talk and on the Epic booth, which was the wavetable synthesizer. And since then, we've hired Max full time, and he's been instrumental in a bunch of important work. And he'll talk about some of that work that he's done recently on the live stream. And then let's see who else on my team. I should have made a list here. So Jimmy Smith, I mentioned, we hired from Coalition, who was the lead audio programmer there, who had just shipped Gears 5. So he is a very experienced line of an audio programmer. He's doing some really great work too. We also had Ryan Manjan, who's our dedicated gameplay audio programmer on Fortnite. And is that it? Did I get everybody? I think I did. All right. So yeah, so 7 of us. We have open headcount right now for Audio Engine QA. So if you are interested in joining the team and helping us test and develop features, so this is for an embedded engine QA role as well. It's not just a tester. It's sort of like basically a important collaborator in our feature development. With input on UX, with feature direction development. There's lots of opportunities for content creation and mentoring the rest of the QA organization. So if you're interested, please apply to do our. It's by the way, it's based in Seattle. That's one important thing I should mention is that the Audio Engine team is based in Seattle. It's in the Bellevue office, and but we have team members kind of spread out now. Jimmy's in Vancouver, and Ryan is in HQ over in North Carolina, directly embedded in the Fortnite content team, audio content team. So that's sort of the overview of the Audio Engine, the team, who's on the thread. I also wanted to talk about the features that we're going to talk about, and then I'll hand it off to people on this live stream to sort of deep dive on that. We got a bunch of demos prepared. So the 4 main features we want to highlight is a convolution reverb that we've implemented in the Audio Engine. If you don't know what convolution reverb is, it's essentially a reverb method that allows simulation of environments using recorded impulse responses of real spaces. So in other words, you can simulate reverberation of real life, but also you can record impulse responses of your favorite analog reverb if you want, and come up with your own sort of reverb. You can also do some really cool special effects. So technically, it's not doesn't necessarily need to be a reverb. It's just sort of a convolution filter that you can put anything in. So you can do fun reversing and things like that. So we'll show off a demo using that. We also want to talk about Synesthesia. It's a plugin that we implemented, and I think it shipped as beta in 424. We're still adding features and making it better. We're using it on a couple exciting internal projects that we got going on. So we built a couple demos with it. We had some guest visual effects artists try it out for a spin. We'll show some of that content. But Synesthesia essentially is a plugin where we're putting in a sort of tool set for audio analysis. Right now, it only contains a non-real-time analysis. What that means is that you have an audio file and you analyze it and generate analysis products, like separate sort of assets that are analysis assets. But we have plans to adding real-time stuff in the future. We'll do a deep dive on that later on. The other feature we want to talk about is sound fields, which is in the direction that Ethan was talking about in our GDC 2017 question. But essentially, sound fields is a sort of general term to talk about encoding spatial information in 3D space. And you may know sound fields is an ambisonics thing. This is sort of a more generalized term for ambisonics. Max will do a deep dive on that. Did I tell who's going to be doing these? So convolution reverb will be Phil's talk. Synesthesia will also be Phil. Sound fields will be Max. And the next topic that we're going to talk about is the Niagara audio data interface. It's really exciting to announce that we've got a pipeline that we've implemented that gets audio data directly into Niagara, which is our tool for doing visual effects on the GPU. As a result, we can do really cool low latency visualizations from audio directly into a VFX system. So we've got some cool demos made by some artists, and Ethan is going to deep dive on that. He made a cool demo that actually 2 cool demos that shows it off, and that's basically it. I already kind of sort of explained the whole setup, the demos, and who everyone is. So I think maybe we should just run the first demo. First thing I want to talk about is convolution reverb. So before we run it, I'll just do a quick setup. This demo was put together by Dan recently. We've actually used convolution on a really nice internal special project that Dan worked on that we can't talk about directly. And it worked really well. So, but we needed to come up with something we could show for this. And so Dan put this together probably 3 or 4 days ago. And it features myself doing some improvisational stylings. It also has a little bit of a demonstration of synesthesia. So if you want to run that demo, Victor.
Running now. All right, pretty impressive demo there.
Cool. So I have the live stream open in here. There's some questions I can directly.
We can do the take the Q&A at the end.
Okay, sure. There were just people.
Or after each presenter, I would say. Yeah, we're collecting all the questions, Aaron. So
right,
don't worry, we got them.
All right. So basically, I'll hand it off to Phil to talk about convolution and how that works.
Sure. So Aaron gave you a small primer on reverb, but I'll kind of back up and just to make sure everyone's on the same page here. So reverb, it's basically capturing a sense of space and sound. it's the difference between you singing in a small room versus you singing in a big hall versus you singing outside. It's all your voice, but it sounds different because of reverberation. So when you're doing reverb in a game or in artificially, there are a couple different ways to do it. You have your parametric reverbs. There's a whole host of different kinds of that. And then there's a convolution reverb. It's a special kind of reverb, you might say. Um, so in a parametric reverb, you might be like twisting a bunch of knobs around room sizes and delays, yada yada. With convolution, your main way to affect a reverb is through an impulse response. So impulse response basically is just a little tiny audio wave file. It's just a sound that you've recorded, but it's a special kind. If you're in a room and you want to capture what the reverb sounds, you make a pop and you catch it with the microphone, and it catches the sound as it bounces off the walls, comes back, and then you have captured what the reverb sounds like at that place with a pop. So if you compare that to let's say a parametric reverb, it's almost like it's photorealistic. It's the difference between taking a picture and doing a little drawing. You've actually captured exactly what that space sounds like. And the other neat thing is with that impulse response, since it's just a sound, you can do all sorts of stuff with it. If you bring it into your digital audio workstation, you can reverse stuff, clip it, chop it, what have you. Lots of cool things. It's just a small sound. So the other probably big difference though between a convolution reverb and a parametric is that it's a bit more expensive on your computer. If you can, it just has to do a lot more crunching. We've optimized it as a lot using a bunch of Fourier time domain convolution multiplication tricks to speed it up as much as we could. But in the end, that what you get for that cost is basically just a lot of cool, interesting, endless possibilities you can do by editing that little impulse response and mucking around with it. So in UE4, the way we've implemented this is it's inside the synthesis plugin. So you have to enable that. And from there, you can take one of the sounds you've imported, turn that into an impulse response in the editor, create a submix effect, set the impulse on the submix effects, and go at it. And here, I think I'll pass it off to Dan to kind of show what that workflow is like.
Yeah, that was a great that was a great explanation.
Yeah. So Dan, by the way, as I mentioned, is the guy who did the implementation, and he's the one who has a great screen share set up here, so he can actually kind of show you the project.
Yeah. Okay, let's set this up. Boom. All right, can you see it? We're good?
Yeah, we're good.
Cool. All right. Yeah. So as Phil mentioned, Impulse is just a wave file that you bring in, which is really fun. As a sound designer, you can go to town with actually editing your wave file. But yeah. So here I have a couple of wave files in my Explorer window, and I'm just going to drop one of them in. Here we go. And the impulses that you've heard in this demo, if you're new to it and you haven't tried them out yet, I actually got them on Echo Thief and Open Air Library, which are just sort of fun places you can go to check out some free impulses. So I encourage you to go out and download some and experiment. And this should be working in the next preview. Okay, so here I just have a wave file from Echo Thief, and I want this to be my impulse. And so I just have to right click, I create an impulse response, and now I have a data file which contains this impulse. And I don't know if you can see this, but there is some small amount of data that you can edit there. The normalization of the file, and this is, you'll want to tweak. Basically, this is like a sort of a pre-mixing opportunity, so you can adjust how much the impulse is normalized, And then you can create a new submix effect. And there we go, submix effect preset. And the type that you will select is the submix effect convolution reverb preset. So my reverb, boop. And then you will just reference the impulse. And then there are some options for surround bleed if you want. This is, right now, this is what I would characterize as a M to S, or a mono to stereo reverb. So you just use a stereo file, which is easy to come by. There's a lot of them. And then you just want to put this on your submix. And then we have a really cool new feature, which we haven't highlighted here, but the attenuation settings now offer a distance send to submix. So you can create, say, a custom attenuation. And if you go all the way to the bottom, you'll see a new category called attenuation submix send. And then you can enable submix sending via attenuation, and then add a list. Now, we haven't done any sort of customization to this presentation yet. Eventually, for the next iteration, we'll be able to hide some of these parameters, whatever's not relevant at a time. But basically, it's the same thing you see on the attenuation reverb send. So if we were to change to a custom curve or to manual send, it's the same parameter list.
That's probably a bug. I should probably fix that.
Yeah, we can. But all you have to know is that for this, you just need to select your submix of choice. And in this case, what's cool is that you can basically create your own effects submix, and then select that submix as your destination for this send. And then just decide how the send levels work and how they map to distance, which is really cool.
Real quick, because there might be non-audio people listening. So when we
Sure.
say send, what that it really means is that when audio plays, the main body of it will go to what we call in Unreal Engine like a base submix, and the submix is an object where actual mixing of sound sources happens, and that's what you actually hear. And you can put audio effects on submixes.
Yeah.
So a bass submix effect might be a dynamic range compressor or an EQ, but there are certain classes of effects where you don't want to put all of the audio. You only want to put a portion of the audio. We call those in audio send effects.
Yeah.
And if you're familiar with DAWs and stuff, that might classically would be like a delay effect or a reverb effect or some other kind of thing where you want to have independent control of how much audio goes to the effect versus how much is dry. So that's what this is essentially doing, is it's hooking up how much gets sent as a function of distance. So the further away you are from a sound source, the more or less you can send to a particular submix that has like a reverb effect on it. Just for clarification here.
Yeah, exactly. So the signal is split, and some of it goes to the normal destination that you have for your sound, whatever that is, and then some of it will go to this effects send submix, this effects submix. And so if we look at the demo example here, you can see I actually have set up 2 effects submixes, and I have a bunch of impulses that I've been playing around with and trying out and experimenting with. And on one of my submixes, I have the effect for the small room. And for the other submix, I have the effect for the big room. And if we look at the small room, you can see I'm using this, let's see, this impulse. It just sounds like someone slammed a little screen door shut. And then for the big room, I'm using this one, which is pretty cool. And what's nice, what's And you can see with both of these, just by eyeballing it, you can see how the sound blooms inside there. And what I like about this one is that sort of noisy quality to it means the sound's going to be very diffuse, and that you'll hear that that second one. There's like the first hit, and then there's the second one that makes for this really nice slap back. And I think that makes the trumpet sound really great. So there's an aspect to convolution reverb that's like simulation, but then there's also an aspect that's like the sort of aesthetics of it. And I encourage everyone to sort of play around and experiment and have fun. And so in my case, I'm doing a little manager. I just have it where we have the sound, and when we cross through this threshold, I'm using just a timeline to crossfade the outputs of the submixes. And when a submix is 0, we don't process it. And so, yeah, that's basically how I set up this little swappity swap. And there are so many different ways you can implement something like this, but yeah. So that was
one interesting thing to point out too, if you are familiar with the audio engine tech that we have in Unreal Engine. Actually, Dan, maybe you could show this, but
Sure.
Traditionally, this is sort of old tech. That's I don't know how old it is, maybe 10 years. Reverbs are hooked up using an audio volume. If you can just go show them what that looks like in the volumes tab.
Yeah. So if you go here, audio volume, you'll see an object, and you can drop it in.
Yeah,
and there's just a bunch of stuff on it.
yeah. And so here, there's a setting here for reverb, and there's an asset we have called reverb, and it's so you see right there, settings. So like reverb effect. So this is definitely an older, I would call this not the direction that we want to take the audio tech in the future. This is extremely limiting on what an audio volume can do. It's like, oh, you go into a volume, only apply a reverb. That to me is not at all extensible. It's not generic. Who knows what kind of sound effect a sound designer would want to apply when they walk into a volume. Like you could do some kind of crazy LSD effect. I don't know. It's whatever you wanted to do as a sound designer.
Yeah.
And so so we intend, this is a sort of future feature, maybe for 26, depends on how we can get this scheduled out in terms of feature sets. But we want to create the ability to have an audio volume hooked up to generic submixes and generic submix sends. That's a little bit more involved of a feature. I implemented the submix distance send for Dan for this special project that I told you that we were using for convolution. I think I implemented that in like maybe a day and a half in the schedule. It would be a little bit more involved to make a more robust generic, I would call it an audio volume, so we can just do arbitrary submixing. We also have some ideas around doing 3D submixing. We have this feature in the audio engine called source buses, which are essentially other sound sources, which are mixtures of other sound sources. So because of that, you can apply effects to a 3D source bus and then have the effect bus itself spatialized, which could be really cool for what I would call source-based reverb. So you could have like a reverb on a sound in a tiny room. It's spatialized according to that room, and then you have your like sort of listener-based master reverb where the listener is. And so there's a lot of cool directions that we want to take it. We haven't yet gotten to that point yet, but I want to emphasize that when you want to use this impulse response, it will not work right now with this sort of backwards compatible reverb effect thing with
right
with audio volume. So you'll have to hook it up. You'll have to learn about submixes. You'll have to learn about how to hook up a submix send and things like that. So it's a little bit more of advanced than our like sort of what I'd call our plate reverb right now that we have in the multi-platform audio renderer, the audio mixer. Which, by the way, Phil was one of the first things Phil did when he came in, is he took that plate reverb that I showed off in 2017 and re-implemented it to be actually efficient. I mean, it sounded good. I was like, hey, Phil, can you make this less expensive? And so he got it to be very nice. It sounds identical. In fact, I think it sounds a little bit better, and it's very cheap. So that would be our parametric reverb that Phil was talking about, the difference between convolution and parametric. That parametric reverb uses the audio volume reverb thing, like sort of because of backwards compat. I wanted to cut that whole thing out like years ago, but I was talk down from the ledge because we wanted to make it as easy as possible for people to upgrade to the new audio engine. And it turned out that was a really good idea because on Fortnite we were able to swap out the audio engine underneath players while they were playing because of things like that. So the content team could go and add a reverb place, and then we could swap out the audio engine. It would just work in the new audio engine. Since now we're flipped over, we don't have to figure out a way to like backwards convolution reverb with the like old reverb paradigm. I don't even know how that would work right now. So, anyways, sort of context and background to this particular problem space.
Yeah. But I will say that if you learn how to do something like that, which isn't a lot of blueprinting, it's just adjusting the amount, the volume output of a submix. I think it just opens the door to so many opportunities in design. So it's worth it.
Yeah, the important thing is that submix send too could be any effect. It's not just reverb.
Yeah.
It's like a generic decoupling of. He just happens to be using it to do a distance-based reverb send, which is one more subtle thing for non-audio people, and even for audio people. A lot of people don't think about this. Is that doing a distance-based send specifically for reverb is very powerful for projecting a sense of three-dimensionality.
Yeah.
The further away you are from a sound source, the more opportunity that sound source has to reverberate. So the more reflections you hear, the more it mixes in. And so by doing a simple distance-based send, in other words, like the further away you are, the more reverberant it sounds, it creates a very compelling sense of three-dimensionality. If you have a whole bunch of different sound sources at different distances, the less reverberant sounds will just naturally sound closer, which your brain will subconsciously interpret as three-dimensionality. It's an extremely powerful technique that I don't think enough games fully take advantage of. If you're making games and you want to make a fully 3D sounding world, this is a very powerful technique.
I think actually that was the first feature you added. For the new audio engine. If you go back to before our 2017 talk, there's a 415 UE415 live stream where we sort of hinted at the new engine and showed off that particular feature.
And it's actually really technically not that challenging, but so many audio engines don't handle it. All right, so I think that was a great demo and good talk. This is format's working pretty well. So the next thing I want to talk about is synesthesia. So in the demo that you saw, that just now with Dan and the trumpet and stuff, Dan had hooked up, just to make it a little bit more compelling, a synesthesia analysis. So you could see the sort of waveform of the flugelhorn. Technically, it's a flugelhorn, not a trumpet. And by the way, Dan, that was really cool. I like the way you did the lighting on the angles there. I thought it
Thanks.
Awesome. But anyways, we have a separate demo that we want to show that just highlights synesthesia in its full glory. And this was implemented by a tech artist. Actually, it's kind of interesting story on this. Is I get pinged randomly from not only the world of game audio, like literally anybody anywhere in the entire world in game audio will ping me. I feel like it's either Twitter or Facebook or Discord or who knows where Slack. We have Slack. So internally, the same thing happens. I get pinged by artists. He's like, "Hey, I'm trying to do like this cool visualization," and he was getting into a black hole, and I was like, "Oh, you should check out Synesthesia, this plugin that we got." And he hadn't heard about it, because we're doing everything at Epic. No one knows. We have just as much problem as you guys out there in the world figuring out what our own engine is capable of doing, as we're just like pumping features every release notes. It's like can't hardly keep up ourselves with what's going on. So I pointed him out to the Synesthesia demo. We actually had just published docs, and he found a couple issues that I think we fixed since then with the docs. He like went to town on making this really cool sort of Synesthesia VFX demo. He did this on his own too, but he's working on some internal special projects, which is doing some analysis stuff as well. And he told me that he's really interested in sort of VJing and this kind of direction in general. I think he had actually a background in that. So I forgot, I didn't mention his name. His name's Simone. And what's his last name? Lombardo. And he did this, and I was like, dude, you have to do this for our Epic booth. This is amazing. Can we show it? And he's like, oh yeah, sure. And then that got canceled. And I was like, hey, Simone, can you give us a video to show? And he actually originally used some music that we don't have licensing for. So he actually just like last night or 2 nights ago went to our YouTube, like sort of license free like music, just picked something he liked, and he said he just dropped it into the project. So what you hear wasn't the music originally designed for it, but I thought it sounded pretty good. So Victor, you want to show that demo?
Yeah. Almost didn't want to stop that. Song's pretty good.
Yeah, I I was really impressed. I was like, that is a really cool, chill song.
Yeah.
So I'll hand it off to Phil to talk about synesthesia. That's another thing that he worked on. He actually came up with a name. I just want to tell the story. I was like, one of Phil's big background, one of the things he's really good at is just audio analysis, DSP. And we're like, we got to put in a plugin. And I was like, man, what should we call it? And he's like, oh, I already called it synesthesia. And I was like, that is a perfect name for it. So cool.
Yeah, that kind of goes back to the fact that I've been working for 10 years on audio analysis. So these names kind of just sit in the back of your head.
But by the way, if you don't know what synesthesia is, that is the sort of condition that some people have where when they hear something, they see color or taste things, or sort of a mishmash of sensory perception. So this is trying to bring visual and audio sensory perception together. So it is a good name for it. So just in case you didn't know what that meant.
Yeah. So it was audio synesthesia is a new plugin in 424. So it's been there for at least one release here. And yeah, the basic idea is taking things you can grab from sound and exposing them to all sorts of stuff. Right now, the pathway is to blueprints. So there are a lot of things you can get by analyzing audio. Right now, we have 3 things in there. There is a perceptual loudness. It's a little bit different than let's say like an envelope follower. Perceptual loudness kind of takes into account that we're really sensitive to frequencies like right around the voice, like like that triggers in our brains really quickly, whereas like a really low hum can be ignored, it can be quiet. So perceptual loudness kind of takes all that into account, so you know how loud something feels. That's one of the analyzers in audio synesthesia. Another one is onsets, which uses the loudness and the changes in loudness to determine when an onset has happened. So if you're clapping, that's going to be really easy. It'll detect every clap. If you're playing a guitar, it might catch every strum. If you're talking, it'll be a little bit more complicated because talking is a really complicated thing. But you get the idea. You can kind of trigger whatever you want to off of audio events. And then the last one that you've seen in, I think, both the demos now is Constant Q. That is sort of like a Fourier transform. We're talking about frequencies and how loud they are. You know, versus a ah, you know, low frequency versus high frequency. But the difference with constant Q over a lot of your other spectrum analyzers is that it's kind of specifically spaced for music, so that each bin that you have can be for, let's say, a single note. You can set up that spacing. Um,
What's a bin?
oh, a bin. Yeah, good point. Each value that comes out of the array that it spits out. I just kind of call them bins, but
I more specifically, it's you kind of quantize the spectra, and you say between this frequency range and this frequency range, we're going to put this into a bucket. A bin is another name for a bucket. So you're like, oh, okay, and then here's
yeah,
a bunch of and then this bucket, and then this bucket. So because you can't have continuous data, so it's a way to bucket sort of your frequency range.
yeah. And so you can say this one bucket is for the note A at 440 hertz with some space around it, you know, because there's always going to be a little bit of noise on either side of that. And so constant Q just lets you do all of that easily, and it spaces it in a way that is both musical, or it's also kind of how we hear things. If we hear something as twice as high in frequency, um, it's going to space that out linearly so it makes sense visually. And
The important point to bring on that is because when we double frequency, it's literally an exponential growth. So to hear an octave is twice the frequency, an octave above that is twice that, is twice that. And so if you actually were to visualize the spectra, it's a logarithmic sort of visualization, and this basically maps that logarithmic perception into linear space, which is something humans can perceive.
yeah, you can imagine like the low A, and then one octave up is right here. And if you don't do this special mapping, the next octave up is up here. And if you don't do the special mapping, the next one after that is like way off the screen over there. For constant Q, it says this is the first A, here's the next A, here's the next A, here's the next A, here's the next octave up A. It's just a really nice way to map this stuff out. The other important note, I think, though, for all this stuff, right now in audio synesthesia, we have non-real-time analysis. You'll see NRT on all the objects, and that just means that it does all the calculations in editor. There's some really good things about that. Basically, all your heavy crunching is done ahead of time for you. So while the game is playing or your demo or whatever, it is just looking up the results and feeding that out to blueprints. That's going to save you a ton of CPU cycles. It does impose a limitation, though. You can only analyze existing U sound waves. So if you're dynamically generating audio right now, audio synesthesia cannot analyze that and spit it out through blueprints. It has to be something that's already been an asset that's been imported. But later versions, it's definitely on the roadmap for adding in that listening to dynamically generated audio. But for now, just NRT, and it saves you a lot of CPU cycles and just exposes everything through blueprints in a very cheap way. Maybe right now I'll pass it off to Dan, and you can kind of show how that's done.
Yeah, sure. All right.
So Dan's going to show how he hooked up the NRT in his demo project, the convolution reverb. Oh, the sort of synesthesia thing. We don't have Simone's project with us. So
Yeah.
we don't know how he did it, but
yeah. So in this case, this is probably a little bit more complicated than maybe you should try on your first try. Just because in my demo, I have a sound source in this actor, and then my visualizations in another actor. So there's a little bit of marriage between the two in the level blueprint. But basically, here are my synesthesia NRT assets, and I have a constant Q and a loudness. And if you watch that video again, which I think we'll post so people can download, the actual ball is lighting up. And that's just me driving a material glow parameter with the ball loudness. So we can look at that in the actual ball. Boop. Okay, yes, I did not clean any of these up. But here you can see my NRT loudness reference is getting the ball loudness. And I'm just going to show you just real quick that you can just retrieve that data. But basically, I'm just getting the current playback time. This is a loop, so I'm doing a little percentage mod. But basically, we get our current playback time, and then we have a little function off of the NRT loudness reference that's like, hey, get normalized loudness at time. So normalized means it's going to be, the value output is going to be from 0 to 1. And that's the most convenient for me to use. And then I map it to whatever the parameter input for my shader, my dynamic material is in this case. If we look at the loudness settings, they're pretty basic. Sorry, this is the loudness reference, the NRT. We have a reference to the settings we want to use, and we have a reference to the actual audio file, which is Aaron's flugelhorn playing. If we look at the settings, which there are default settings, and you can, it's fine to totally just use those. But I created a settings just in case I wanted to change anything, and I looked at it and I said, no, I didn't want to change anything. So in this case, for the loudness settings, I didn't change anything. So these are just the default values. So I could have left it at the default, but you can create your own settings and tweak these values, the analysis period. So if I wanted a smaller data set, I might increase the period size. I might want to pick out a specific range of frequencies, which is really cool. If I just want to measure loudness from one part of the audio. And then curve types, I don't know, maybe Phil can explain that.
Yeah, there's when you're talking about audio perception and how you weight different frequencies, there's a handful of different ways that they've measured people's sensitivities to different frequencies. This could be in an advanced setting, but it just changes which one. You can look these curve types up online for equal loudness contours and see all the graphs of what they are. But these are kind of standardized ISO, whatever versions of curves.
Cool. Yep. And it looks like you have some nice tooltips to help people out, which I should have looked at. All right.
So one quick thing on this is because this is non-real time, you can actually get really creative in terms of how you do your analysis. You can, if you're the person who authored the music, for example, you can actually break out your music into different stems. Yeah. Stems are like segments of the music. So you could say, make a audio file of just the bass drum, or audio file of just the drum track, audio file of just the bass instrument, audio file of just the music, so you could actually split your audio into a bunch of different pieces of music, analyze each of them independently and get sort of different bodies of data from the non-real-time analyzer for whatever you want to look at. Maybe the drums, you want to use the onset detector to trigger off events, but you obviously don't care if there's a vocal track, but you might really want to get a cool constant cue on the vocal track, so you get some awesome, and you could use different settings for the different components. So like if someone's only singing within one octave, you can really fine tune and get nice, like each individual note when they sing could be a different band, and then you can get all those pieces of data and drive different visual systems. You could, and because it's non-real time, you have access to the whole data file. You could generate levels. You could generate entire crazy star fields of stuff that you fly through in VR. Who knows what you guys want to do? And then, but then when you play the music file, it's just one piece of music. So it's only just one source. And everything should be pretty well in sync, unless you got some crazy rendering issues going on. But with different components analyzed. And that's what Simon did with his demo, is that he actually modified the audio files to get different analysis components, so that you could just get the bass driving the sort of thing in the center of the screen, just the drums on the, so he like broke out the visualizations nicely, better than you could do at all with a real-time analyzer.
Yeah.
So
yeah. So in this demo, it was just a solo instrument. So,
which by the way works really well for constant cue. You could really nicely see that those spectra.
Yeah, so I did do some adjustments to my constant Q settings. So here, similarly, if we look at the constant Q reference, it's just the reference to the audio file and then settings. The default settings, obviously, you can use, totally fine. In my case, I actually adjusted some things. I changed the starting frequency to 55 hertz, which I believe is an A. And then I doubled the number of bands because I just wanted all the bands. I think 48 is the starter default parameter. So this is how many of those bins that Phil and Aaron were talking about.
96 is pretty high too. That's a
96
large
is
number.
pretty high. Yeah, I wanted a lot.
That's
I had a whole wall. And then how many bands per octave? So I left this as default. 12 semitones per octave is totally fine. So
I mean, that's like all of the keys on a piano.
that's all the keys on the piano, exactly.
Yeah, those are magical number settings.
It's not.
These right
It's
here.
it's actually more than all the keys, right? Because I have 96. So there you go.
Well, so number of bands, since you have bands per octave, what that means is the number of piano notes. You know what I mean? So
yeah. Yep. Yep.
So you could have the
Yeah,
96
so
key keyboard.
So when I said semitones, that would be like every key, all of the white keys and all the black keys on the piano.
And 55 starting frequency was chosen because of one of the which note is 55?
That would be an A, I believe. But
yeah,
maybe...
so A. So basically, Dan knows that 55 hertz is tuned to an A. So assuming my trumpet playing is in tune, this should pick up, the individual notes, which it looks like it does, right? When I'm playing, you can kind of see it moving around nicely, discreetly on the notes.
Yeah. So, one of the things that you see in and you'll see in other visualizations we have coming, that they're like a bunch of bumps, and that's due to this thing called harmonics. So every sound, we won't get into it in any detail, but just know that every sound has like a little fingerprint for that sound, and that's why two different people singing the same note sound like different people. And that fingerprint is represented in that sounds harmonics. And so that's why you'll see actually more than just one little, when Aaron's playing one note, you'll see actually a bunch light up. And that's because that flugelhorn excites particular harmonics, and that gives it the characteristic of a flugelhorn.
Otherwise, it would sound like a sine tone.
That's right. Yeah.
By the way, this could be a cool demo in the future to actually use a sine tone
to
show the selection of individual notes as it goes up the scale.
Maybe someone in the community will make one of those.
Yeah. Hey, do it, and we'll retweet it.
So just real quick, we'll go over to my little blueprint actor on the wall here. And in this case, I just have a little blueprint actor that generates a bunch of cubes. When you start up, it generates 96 cubes, as you can see here. And then I have a function for setting the scale of the cube. And most of this math is me just sizing the cube based on how many cubes there are, that sort of thing, which you don't have to worry about. The meat will be in the level blueprint where oh yeah, you can quit the game. That's nice. Always convenient. And then here, here we go. So I'm getting the playback percentage again, like the other one you saw, with the material driver. And I'm just getting the time value in seconds of my audio. And then I'm saying, get the normalized channel constant Q at time. So again, I'm looking for a normalized value that makes it really easy for me to deal with, because I know that the output's going to be somewhere between 0 and 1. And so that way I can drive the scale of my cubes however I wish. I can always multiply it by however biggest size is going to be. And then it spits out an array. In this case, it's going to be spitting out an array of 96, which might be a lot overkill depending on your application. But for me, I thought it was fun because it's a whole wall. And I just had the one anyway. And so then I just go through a loop and I resize each cube at its index. And that's how I did that. That
One
think,
important thing to highlight here is the if you look at your blueprint there real quick, Dan, to show the
oh,
how
you want
you
me to go back?
retrieve
Yeah.
just how to retrieve the data. I just want to
Sure.
it's important because I think a lot of analysis techniques might there we go. So right here in the get normalized channel constant queue time, you uh don't need to actually hook this up to a playing sound file. Like
That's
this
true.
is just a getter that can be called at any point. So you could have a level generation, like I was saying, like the level loads. You just have a thing that just goes through and retrieves all this data. Um, we could, in fact, maybe add a C++ API to just get all the data. I think it actually might be easily accessible. So if you're a programmer, you could actually just get all the data and then do like generate a level or something like that. This just is a convenience function to use seconds because that's how the audio file is hooked up. But and so what Dan has done here is independently played the file, independently query where that file is in its
Yep.
position, and then query the data here. So it's actually totally decoupled. It has nothing to do with playing the audio file. He could simulate
Yeah, that's
this.
right. What I wanted in this case was the wall cubes to move in synchronicity to the music.
Yeah.
And so that was the only reason I'm
Of course.
retrieving the playback
Right.
percent, right? Is because I want to know the currently playing file, where I am in the file, and then to get that particular time period of analysis and spit that out.
Something's going on with your screen, Dan.
Uh,
All right, cool. So I just
Yeah.
wanted to highlight that just to make sure that it's very clear that it's just a retrieval. Cool. So any other
I
points
just
to make?
wanted to add one small little thing about that too. You set up all this stuff to set up the level, to do the animations, but really you can just, if you all of a sudden want to use a different sound wave or a different sound file, it's so easy. You just put a different one in the analysis and play the other file, and it all automatically works. You don't have to reconfigure a bunch of stuff
yeah.
to do that. Just a nice, easy drag and drop kind of operation.
Oh, one more thing. We have plans. Phil and I have talked about this to make the sort of analysis step more intuitive because it's like sort of starting frequency, number of bands, and so we're like, wait a second, this. Why are we making people do math? So we plan on adding in future versions sort of convenience functions to be like which scale you want to listen to, which chord, which mode, whatever. We can do that kind of thing behind the scenes. So you don't have to like know that 55 hertz is A. You can just say, you know what I mean? Like it, going to Google and looking up what frequencies are from notes is kind of silly. So we can just do that for you. But just to let you know that under the hood, it would be the same. We could just make some convenience functions to help on the analysis. All right. Any other points on synesthesia before I move on to the next tech? How are we doing on time? Okay, so we got 2 more pieces of tech to go, so let's move on.
We're good on time.
So the next, I mean, we don't technically have a time limit. I just don't want to. I'm starting to get hungry. It's lunchtime. So, the next thing we want to talk about is sound fields. And it's going to be kind of a 2-parter with Max and Ethan talking about it. But I'll let them go into detail, but just to remind you before we set up the demo that what this is demonstrating is playing audio that is encoded in a special format that is independent of the audio channel output. So it's like not just stereo, it's not just 5.1, it's not 7.1, it's channel agnostic rendering, as Ethan asked in 2017, which I think is a great way to characterize this. And so what this demo is showing is essentially audio files played in a sound field, and then showing that we can do transformations of that sound field before rendering the audio output. So the best way to experience this kind of tech is with a surround sound system. It works in stereo. This is all a stereo video, but I encourage you to go home and try this stuff out if you have a surround sound system. It sounds like almost magical to hear sound field rotations in like a 5.1 or 7.1 surround sound system. All right, Victor, roll it.
back.
Did that sound like the left and right channels were backwards? It was hard. I don't know if we validated it. In previous live streams, the left and right were swapped.
Should be playing all right here.
All right, so maybe I'm not hearing it right. All right, so I'll let sort of Max take this one away.
Cool. So yeah, now we have native ambisonic rendering in Unreal with 425. And ambisonics is a way to represent 3D audio, like Aaron said, which is decoupled from the end user's speaker setup. So they could be using headphones or a 5.1 surround system. Ambisonics doesn't really care. And it does this by representing audio as a sound field instead of storing speaker channel information. So that means that ambisonics is trying to take a sphere of space around the user and represent all the sound wave and air pressure activity that would be going on in that sphere of audio, assuming all the audio sources that we want encoded in that sound field are coming from outside that sphere. And then we can rotate and transform that sound field around the listener. This sound field bed that we're talking about can either be captured with a sound field or an ambisonic microphone, or it can be authored in sound design software. And so while sound fields are not directly associated with any particular speaker configuration, they can be decoded to any speaker configuration, which is what makes it so flexible on the output side. And for graphics programmers who have experience with spherical harmonics for lighting, it's the same exact math behind ambisonics. We're just using a set of coefficients for each audio time step. So what does having native ambisonics rendering in Unreal get you? The benefits are probably pretty familiar to sound designers who have used this before, but it's great for world-locked ambient beds. Meaning, imagine you're creating a sound for some gameplay that takes place in a jungle, and you want to create an immersive jungle ambience, like an audio backdrop, and you want an ambience that is representing all the sounds that you would hear in that environment, and they're all around you, and it's in a compelling way. Without ambisonics, you have a couple options. You could go try to record a stereo file of that ambience if you have access to a jungle or whatever area you care about, or you could find one online. But when you drop that in the engine, you run into an issue where that stereo ambience is not locked to the world, it's locked to the player. Meaning if I first start up your game, I'm in your jungle level, it sounds great, and I hear all this cool stuff going on, and I hear a bird chirping over here. But then as soon as I rotate as a player, all that stuff follows me. It seems completely static. Which is not the worst thing, but it's not really that immersive because that's not how we hear things in real environments. When I rotate, I can hear that my orientation is changing because everything else is staying where it is in the world. So to fix that problem without ambisonics, we could also try dropping in a bunch of mono assets and place them in the world and spatialize them. And that would work, but it would be really expensive to spatialize and render that many audio sources just for something that's supposed to be your background audio. It's there for immersion, but it's not critical to gameplay. So now with sound field rendering, we can author or capture that ambisonics file. Right now we're supporting a couple of first order formats. We can drop it in the editor and drop that asset in the level and hit play. And now things are working the way we want. So all those elements of your ambience are now staying in the world, and I can rotate independently, and it all sounds great, and it feels like I'm actually there. So it ends up being more like a dynamic skybox for audio, or like a 360 degree video for audio. It's important to note the rotation of that sound field to compensate for the user changing their orientation is a constant cost, no matter how much stuff you decided to throw into that ambisonics bed. So rotating a first order ambisonics bed is always the same amount of work on the CPU compared to the spatialized mono source approach, which would get more CPU intensive the more sources that we add. And in Unreal, we're also rotating each ambisonic source separately from the listener orientation based on that actor's transform. So meaning there's the step at the end where we rotate the sound field based on the listener orientation, but each ambisonic source can be rotated using the actor's transform, so that if you need to make adjustments, rotation adjustments to that asset that you dropped in the engine, you don't have to go back to your authoring tool and re-export your asset. You can do that all in real time. And along the same note, you can animate that actor's rotation, and the sound field will animate too. So you have some cool creative effects where you're spinning stuff around in real time. So Ethan, yeah.
I was going to say, you mentioned the word order. Do you want to briefly talk about what that means?
Oh yeah, so ambisonics order is basically the higher order ambisonics is, the higher spatial resolution that you have. So first order, if I hear a bird chirping in your ambisonics bed, it would kind of sound like it's coming from this general region. If I go to second order, third order, I would be able to pinpoint that particular element to a smaller area. but it also takes up more space in RAM and on the hard disk, and it gets more expensive to apply those transformations. So right now in 425, we're launching with first order only, which is relatively cheap and is great for ambiances that don't require like pinpoint localization for the user. But we do have a lot of the infrastructure and math is there for higher order. But first order is a code path that has actually been exercised by our internal project. So that's what we're shipping in 425. So Ethan got all this set up and integrated into the existing summix graph with the addition of Soundfield summixes, which is a cool new feature I'll have him talk about.
Yeah, I talk about that. Thanks a ton, Max. Actually, that was really good. That was a terrific explanation of Ambisonics.
Well done.
Yeah, so Soundfield summixes. Really, the core problem that Soundfield summixes are trying to attack is spatial audio, right? How do we actually mix down audio from a certain amount of sources out in the world down to the speakers in your living room or your headphones or what have you, in order to help you localize those sounds, right? And the thing about spatial audio in games is that there's no real one-size-fits-all solution, right? You may have heard of HRTF rendering, right, in the past. You might have heard it in the Sony live stream recently or in games. There are various games that have HRTF rendering now. But it's basically something where you take audio sources and their positions, and you apply a certain amount of filtering as well as panning to those sources to emulate the actual filters in your ears, right? To actually help you localize that audio the same way that you would localize that audio in the real world. And the thing is, doing HRTF rendering for each individual source can be prohibitively expensive at scale when you have several dozen sources out in the world, right? So a lot of these HRTF solutions, as well as other various spatial audio solutions, Google Resonance, for example, is a very popular HRTF rendering solution, mixed down to an intermediary format, right? A single sound field representation, as both Aaron and Max alluded to. Google Resonance in particular uses ambisonics, right? Which is, as Max alluded to, a spherical harmonic representation of spatial audio, but it could also be a virtual source speaker array, right? So say it's a virtual 7.1 or 12 speakers that we down mix to. It could be clustering of those sources, right? So you have 4 sources over here, and we dynamically downmix those to a single speaker as we go. Those are used, those intermediate sound field representations are used to render a single spatialization process to that sound field representation to what your physical audio outputs are. So the thing that we realized with sound field summixes is we needed a really good way to actually expose that intermediary sound field format to the user so that they could have total explicit control over their spatialization pipeline for their specific project, right? So what sound field summixes get you is a lot of functionality that we simply did not have previous to them, right? So you can create an ambisonic summix, right, which is a type of sound field summix, and send sources to that ambisonic summix, and they will be encoded to ambisonics and downmixed to an ambisonics bed, right? And then you can take that ambisonic summix and then connect the output of that ambisonic summix to the input of an Oculus Audio sound field summix or resonance audio summix, and we'll actually spatialize and binauralize using Google Resonance or Oculus Audio that ambisonics bed using that summix output. You can also do things like send ambisonic sources to ambisonic summixes, of course, or to Oculus Audio or Resonance directly, or even add a send, as Aaron and Dan alluded to. Summix sends are when you can say bus audio to a separate summix than your main output. And you can send that to, say, your reverb summix, say a reverb effect, and we'll decode that ambisonics output so that we can actually pipe it to the same reverb effect that we are sending regular old 2D audio, right? So it's really powerful. You can really do whatever you want with it. You can even have, say, a Resonance Audio sound field summix and an Oculus Audio sound field summix in the same project, in the same summix graph. You're sending some sources to one and some sources to the other. We can have multiple HRTF renderers in your project. So it really gives you complete control over the spatial audio pipeline.
One exciting idea that we've been thinking about as an audio engine team is sort of rethinking the idea of audio effects in the paradigm of sound field effects. Because one of the big issues with DSP effects is that there's this assumption of channel-based sort of processing. So channel-based would be like left channel, right channel, center channel, all that kind of stuff. And once we get into this domain of a sound field submix, so now we have a submix that's in a sound field encoded format. What does it mean to apply audio effects in a sound field format? So we've been sort of thinking deeply about how that could look and ways of doing that and things like that. If you want to talk about that, Ethan, I just kind of wanted to bring.
Yeah, for sure. Architecturally, that's in there right now in 4.25. If you want to try for yourself to try to create a DSP effect for an Ambisonics bed, for example. And it's something that we would really like to try in the future, right? When you think about convolution reverb, right, it'd be really cool if we could take Phil's awesome convolution reverb, be able to sample our Ambisonics bed and apply convolution reverb to that Ambisonics bed.
Going into an environment with a Ambio sound field microphone, recording a sound field impulse response, convolving your sound field audio with a sound field impulse response, and get a full 3D, convolution reverb experience could be a really interesting direction to go.
Exactly. And that's kind of the substrate that we've provided in 4.25, and it's a really exciting direction for spatial audio in our engine architecture.
One important thing sort of Ethan alluded to is that all of this stuff is plugin extensible, and it's also platform extensible. So platforms that may have hardware acceleration, either mobile platform or console platform, for various types of operations like this, either through convolution or through sound field or things like that, will be able to create platform-specific sound field formats that allow hardware acceleration on some of these directions, which is architecturally really powerful, that we're flexible enough where we could say, like, on platform A, actually use their particular, underlying API to accelerate these operations.
Yeah, exactly. And for a lot of those situations, right, say you have a hardware processor that goes directly to the speakers. Previously in the engine, we've found that pretty challenging because, you send your sources to a hardware accelerated spatialization solution, and then the user says, or the developer at least says, where did it go? Where did my sources go? And we don't really have explicit visualization of that in our submix graph, that we've actually sent those sources to an external send to hardware processing. So with this, we've also implemented the substrate for endpoints and sound field endpoints, where we can actually send submixes to, say, hardware accelerated processors, and then it'll be sort of fire and forget thing. And it's very explicit in submix graph that when you're sending audio to this endpoint, it is going somewhere else that we no longer have control of the audio signal.
Yeah, you're kind of conflating two things, sort of sound field submixes and endpoint submixes. They were kind of done together, so they are somewhat related and conflated. But the bigger idea on that, just to put a pin, like a really clear pin on it for people listening, is that the submix graph in 4.25 got a lot more complicated. We got sound field submixes. We also have this other concept, which is an endpoint submix. And we have a lot of ideas of where we want to go with this thing. But an endpoint submix, just to be super clear, is essentially a submix where the output is not in the graph.
Exactly.
It's essentially a output submix. It's going to some output. That means in the future, we just ran out of time for 4.25. It's probably 2 or 3 days of work. But we have ideas of allowing in the submix graph games to render arbitrary numbers of literal hardware devices. So like on Windows, if you have, like, I've got, I think, literally 20 audio devices hooked up to my computer here. Like, if you wanted to route from UE4 to 20 different audio devices and create an insane installation, like, you wouldn't want to ship a game like that. Like, you make your game and you're like, okay, this game requires 20 audio devices really for you to experience this. But if you wanted to do an art installation, we're really close to being able to support that. We just ran out of time for 4.25. I said, hey, Christina, who's our engine producer, is like, can you hold back all of 4.25 for like another couple weeks so we can do a couple more features? And they said, no, Aaron. So we'll have to get it in future versions. But basically really close with these sort of really interesting directions to take sort of audio rendering. And what an endpoint can be crazy. It could be sort of your controller rumble pack. It could be, I don't know, who knows? It's extensible. So you guys out there listening, you people out there listening can imagine what an audio endpoint can be beyond our conceivable beyond our conception.
We had a
So-
question.
For sure.
Sure.
We had a
Sorry, go
question
ahead.
on the Soundfield demo and Ambisonics. They were curious if it will work in VR out of the box.
Of course. Yeah. But so I would say all VR is a stereo output. Like from our perspective, there's audio engineering rendering. It's stereo. It doesn't, by the way, have to be stereo. And this is an interesting direction in VR. It's something that I've been wanting to play with since VR became a thing like 3 or 4 years ago. We're really close to being able to actually try this out. But the traditional way of thinking about VR is like you put headphones on and you play your game, and we do all our rendering and with headphones. In my opinion, the problem with that is that headphones, like I'm wearing this right now, it takes your human mind out of sort of the experience of the way your ears normally work. You don't like walk around the world with headphones on, right? This is an exciting direction of like the Valve Index, where their headphones are off your ears, which is a huge direction.
Yeah.
But still, it sounds like speakers hovering above your ears, which is not which is not real. It still doesn't sound real. It's a good direction. One thing that will sound more real is surround sound systems. So I am convinced, and I haven't done this yet in VR, but if anybody's making a VR game, you should try it out. Is a hybrid technique where a portion of the audio is sent to surround sound and a portion of it is sent to your local headset. So with this sort of direction with the submix graph that we've implemented, you could totally do that. You could have audio in your game route dynamically to a submix, which is doing HRTF rendering with the stereo output. So you could maybe do it dynamically based on distance. So if a sound comes in nearby, route it to the HRTF submix output, which then goes to your headphones. That's endpoint 1. And then if a sound is far enough away, dynamically route it, which you can do with our audio engine, to a submix, which is a sound field endpoint. So now you've got like total 7.1 sound field rendering dynamically. So it's not just playing an Ambisonics file. It's like a sound source rendering into sound field, playing on a sound field submix, which is going to your surround system. But then as it gets closer, it'll blend using submix sends to an HRTF render, which is going to be spatialized locally. So you could get the sort of best of all worlds. So you get like the beautiful nearby spatialization with the distance, ambient thing. And then also subwoofers. Subwoofers are huge for those big things. So you could say like this audio, you could make a separate endpoint, which is just subwoofing, whatever. You can route audio dynamically to go to the LFE effect. But we have some ideas on doing dynamic speaker mapping too, so you could even go crazier in the future. But you could imagine a really compelling VR experience where it's surround sound and headphones is sort of the idea.
Using a sub pack is a really nice way to add add a subwoofer to your VR experience.
Absolutely.
And
Yeah, for sure.
I believe Dolby did a demo where they actually did what you just talked about. So there's been some experiments in that area. It's pretty exciting.
Yeah, absolutely. Yeah, sending audio to haptics is like one of the coolest things in games right now, in my opinion. So yeah, actually, Max, sorry, go ahead.
Oh, I was going to say the only problem with this sort of endpoint routing thing is it would really only work on PC where you have multiple output devices. When you get to console, it's like, here's my audio output, and then that's all you got to work with. But even with VR experiences on console, there's ideas that we could experiment with where we send to 7.1, but like route the audio in an interesting way where like the left and right channel goes to headset. And then, you could imagine some weird sort of experiments in that direction. But traditionally, you're not going to be able to have this kind of crazy routing capabilities with console. Just wanted to point that out.
For sure, yeah.
What were you going to say, Ethan?
Oh, no, I was going to send it back to Max, actually.
Oh, sure.
Max, if you want to just say anything else about Ambisonics, Max's Ambisonics rendering, encoding and decoding is awesome. It's been great to be a customer of it. So
if you want to, Max, when he was a student at DigiPen, did a really cool visualization of sound fields. I don't know how to share that, but I don't know. Do you have a website people can go? Because it's a really cool visualization.
I think I have a YouTube link. Yeah.
I mean,
If you want to drop that
check out my
to me
SoundCloud.
or
check
in
out my-
chat.
Yeah, we could send it to the stream chat. If you want to give it to Victor, he can paste it in. But anyways,
Okay.
he built this really cool student project that lets you like actually try all the different sound field configurations and then visualize what the spherical harmonics look like. So you get a kind of and it's all live and it's a really cool demo.
That's
student
fun.
project. right.
Yeah, I'll just wrap up by saying, so while it plays nice with all these other endpoints and things that Ethan discussed, we do have a native decoder. So if that sound field submix hits your final audio output, it'll get decoded to whatever the device
Yeah.
is.
Yep.
Cool. And I think I'll hand it over to Dan to talk a little bit about
Yeah,
Python and
yes.
stuff like that.
So in the demo that we just did, I made the subtitles late last night. Dan gave the video and he went to bed, and I was like, oh, this is great. I had assumed that the Thunder was done with a Soundfield microphone, but in fact it wasn't. So the subtitle's wrong, and we wanted to show sound designers how to author content in this sort of domain, and we tried a whole bunch of different solutions, and Dan came up or discovered this is the sort of easiest workflow. We just wanted him to have an opportunity to show you guys how he did it.
You're muted,
Yeah.
Dan.
Okay. All right. Yeah. So here I have Nuendo. I have a window in Nuendo open, and you can see I have a little Thunder asset that I liked. And what I have set up here is an Ambisonics group channel, which you can just create any a group track. If you go to configurations under the more, you can see there's a bunch of cool extended channel configurations to pick from. And I just picked first order, which is basically a 4-channel group. And the way that I have it set up in my DAW is I actually have it set up to stereo out first, so I can monitor on my headphones or on my speakers. But then I have a send to a dummy output, which is a 4-channel output for so I could pick that as my export channel. But in general, I have just these stereo files, or rather one stereo file that I'm just crossfading instead of doing any sort of automation. I did this late last night, as you can tell from my super simple mountain landscape.
You know, when you said that to me, I was like, I don't know. I hear rain, but I see a glowing, or I called it in the subtitle, glowing orb in the sky. So you referred to it as a sun, but looking closely at it, it was literally a glowing orb.
I have, I had a glowing, I reused the orb from the convolution.
Oh, nice.
Demo.
You just dropped that in. Yeah, anyways, it was a really trippy demo. I thought,
yeah,
cutting it at 12:30 a.m. I was like, man, this is putting me to sleep. I was like,
yeah. So anyway, the panner going from a stereo to Ambisonics format is really cool. It basically has little head with 3D spheres, and I can position the left and right channel however I want. And then I can do some things like adjust the diffuse size of the source and that sort of thing. And so here I have the Thunder clap starting out forward distant, and then I have it diffusing out, and then I have it like basically around the listener, and then sort of tailing off, but still kind of diffuse, and the output file is just a 4-channel file, which, as you can see, it's probably a quiet file here. But yeah, so exporting that, it's just a 4-channel file. And the only thing that you want to sort of keep in mind right now, we don't have like an import wizard, and that's maybe something we can look at in the future. But right now, the most convenient way to import an Ambisonics file is to add to the file name the particular type of the format of the Ambisonics file. We are supporting 2 first-order formats, as Max mentioned. Right now, it's Ambix format and Fuma format. And they're basically very similar, except with the sort of channel order has changed a little bit. But generally, they're both 4-channel files, and so you'll need to add that to the file name. Under the hood, we're treating them all as sort of Ambix. So when you import Fuma, we actually convert it to Ambix. But Nuendo is exporting Ambix files, and so I used that. And let me just switch over to the engine real quick. And you can see here, I have my 4-channel Thunder clap. And if you have already imported an Ambix file and you didn't add it Ambix to the file name, you can always flag it as Ambisonics. But it's not going to know that it's Fuma. So if you've imported a Fuma file without adding it to the file name.
Well, this is actually kind of an interesting subtle point. The reason why we need to do that is that Ambisonics files are really just regular old
They're just WAV files. Yeah.
There's no way for us to know. You kind of have to.
Yeah.
We don't know if the file name or you have to tell us.
Yeah, exactly. We don't know if it's a 4-channel surround file, which is totally valid, or if it's an Ambisonics file.
And you can actually play an Ambisonics file as if it was a 4-channel file.
Yeah.
It's actually kind of an interesting way to learn about what the format looks like.
Yeah. So a 4-channel Ambisonics file is basically a pressure channel as the first channel, and then the other channels are your X, Y, and Z vectors. And so the loudest channel is the first channel, which in quad's surround format is the left front channel.
It'll make your left channel real loud, and it does not sound good. So you'll know.
Yeah, that's actually how sometimes I try to determine if it's working or not. If I've missed something, if I just hear stuff coming out of the left channel and it's very quiet everywhere else. But anyway, other than that, it's actually really simple. I can just drop it into a level and hit play, and it works like any other sound.
It automatically locks world orientation.
Yeah, it locks the world orientation. The actor forward is this X vector. So if you look, so as you noticed in my Thunder file, I had the sort of source start and sort of kind of little to the left of the front of the head, dummy head. That's going to be the X vector here. So if you need to rotate, you'll just rotate your actor so the X vector is pointing.
Actually, it's kind of a misnomer to say it's world locked. It's actually source orientation locked. So the orientation of the Ambisonics file is actually that source. So you could write a blueprint script that rotates this, and you would hear the sound field rotate.
That's what I did for my Thunderclap, right? Because I wanted the Thunderclap to be starting in this direction.
Yeah.
And so I have this little blueprint. And basically what I do is I just get the camera location, and I get the sound source's world location. And then I just get a normalized direction vector based on that. And then I get the difference between the source's forward vector and that vector, and then I create a rotation, and then I set the new world rotation for my actor that way. And I was I was also able to, sorry, now I'm like ultra wide mode right now. I was also able to have an actor update, so it's always facing away from the camera, which was interesting because then it was like as I moved around, it was almost like a regular sound source. So it's pretty cool. You can update, you can change, you can rotate. It's really wild, and you should play around with it. And there are some free tools. I should mention there are some free tools. I have Nuendo, which is kind of fancy, but there are some free tools out there for authoring Ambisonics files, and there's some Ambisonics files you can just locate online. So have at it.
Cool. Cool. So thank you, Dan. Great job, guys. So our last piece of tech we want to talk about is our Niagara audio data interface that we've implemented. Kind of wanted to give a sort of little backstory on it, sort of a dev diary kind of a thing. We had, so Niagara, if you don't know, is a new tool that is replacing our old VFX system. made what was it? What was it called? The
Cascade.
Cascade. And so Niagara is sort of the new version of Cascade that is way more powerful and consequently way more complicated. But one of the exciting things about Niagara is they have this thing called a Niagara data interface that allows things to just arbitrarily pipe data to it. We're like, we should hook up audio to that. And we'd been wanting to do it and it just never got scheduled. And Ethan one day came in, he's like, hey guys, I've been talking to the Niagara team and I think I got audio working in Niagara. And this was like back in November, and he spent a couple days doing it, and he made some early compelling demos that he shared with the VFX team, and as a result we became committed to getting this thing actually shipped by 425. It was like, this is too amazing not to ship. I remember the day that we hooked it up, we were like in the audio programming office literally like high-fiving each other for like 15 minutes straight. I was particularly excited, but we were all like, wow, that's awesome, like high-fiving. It was very exciting. But then it was like we got pulled off onto other special projects, and then as GDC came up, we were like, oh, we have to actually schedule time to get this thing out the door. And so we did, and we got some cool demos. So we got 3 demo videos that we wanted to. Sorry, my kid is, it's nap time. Yeah. He wants a hug. But anyways, got 3 demos we want to show. First one, the first 2 are made by Ethan, and the third one is done by a VFX artist that another VFX artist at the company who used it to hook up to Niagara. He's one of the principal tech artists that works with the Niagara team. He's sort of like the Dan Reynolds of VFX. And so then I'll let Ethan kind of do a deep dive on that tech. So Victor, play the next demo.
Hi, my name is Ethan. I'm an audio programmer for Epic Games, and in this video I'm showing off a cool new feature in 425, which is the ability to pipe audio output directly to any Niagara particle system in real time. So there are 2 main ways to use audio in Niagara. The oscilloscope interface, which the blue particles are currently using, samples the waveform of the most recent audio directly with no additional processing. The spectrum interface, on the other hand, is being used by the orange particles, and this performs an FFT to sample the frequency output of the audio engine, and additionally uses what's called a constant Q transform to make sure the output of the spectrum interface maps well to music. As you can see, we have a little bit of a stereo thing going on here, because the systems on the left side are using my voice output using the microphone, and the particles on the right side are actually using my bass, which is currently hooked up to the engine. You should be hearing that out of the right speaker and seeing the response to that on the right side of your screen. As you can see, as I walk up the bass, the big lobe and the spectrum particles on the right side move upwards in frequency towards the right side of the screen. We were able to get the system to have very low latency by serving audio directly from the audio render thread as soon as it's finished rendering directly to the render thread to be served to the GPU. This allows us also to minimize the CPU cost of these systems pretty significantly. Alright, that's all I've got. Thanks for watching. That's also the only bass riffs that I know how to do, besides maybe like... There we go. Cool.
Nice.
Cool. Is the video done? Sorry, I'm not looking.
Yeah,
at
yeah,
it
it's
done. Very cool. Very cool. It's also probably really funny that the walkthrough has my voice in the left channel, and I just come back to the center channel. Cool. Great. Yeah, I'll talk a little bit about Niagara VFX and what that was. So Niagara, as Aaron mentioned, is the new VFX and particle system in Unreal Engine. There's some really good documentation on it in the Unreal Engine docs. And you could always kind of drive Niagara particle effects, or not always, but in previous engine versions, you could do it with blueprint parameterization, right, that you got from our audio analysis tools. But what we really wanted here was we have a huge amount of data coming from the audio render stream, as we talked about, that we want to drive particles off of with really low latency, right? And the Niagara team is great, and they created this system called data interfaces. They're used for a variety of different engine subsystems to interact with Niagara particle effects, right? So for example, meshes, right? If you have like a character mesh, right, the shape of the character, you can have a bunch of particles, light-emitting particles, sample that character and create this cool little hologram effect, right? If you have a collision in the game, right, you could drive, say, sparks flying off of a collision between two metal objects using one of these data interfaces. So naturally, creating a data interface for audio was a super good fit. This is like one of those really cool cross-discipline collaborations that we do in the engine that I kind of live for personally, and I think a lot of the rest of the team does also, where I could talk to the networking team or the physics team, or in this case, Niagara team, and really deeply integrate audio at every level across the engine.
This is actually one thing.
Sorry, go ahead.
I was going to say this that really an exciting aspect of having our audio engine in UE4 now being capable of doing this sort of activity is huge, because at Epic we have all of the other world experts in these different subdomains that now we can sort of come up with really cool, deeply integrated collaborative solutions for audio, VFX, physics, networking, all that kind of stuff, which is very exciting and kind of a unique aspect of where we are as an audio engine in UE4.
For sure. Actually, if I could nerd out for a second, like a big part of this was we've created a couple of new classes in our C++ library for routing audio signals arbitrarily between whatever systems you see fit, including stuff like mixing audio inputs that may be coming in from different systems and different threads to splitting outputs to multiple threads if you want. And
the audio
data interfaces use them.
The audio routing is also thread safe, so the kind of handle a lot of the tricky aspects of getting audio from one thread to another thread. I actually used it recently for a feature that'll come out in 4.26 called audio buses. Yeah. So essentially, it's the sort of modular synthesis analog of an audio cable, like I have behind me here. So we have these audio buses. So in UE4, we'll actually be able to create a virtual version of that and be able to arbitrarily route audio from anything to anything through assets, but also and it uses his C++ API that he's talking about. So it's very cool.
Yeah. If you're a C++ programmer watching this, check out, I think it's called multi-threaded patching.h if you're curious about them, to check it out yourself. But
so
otherwise, also we have a couple more demos. So yeah, go ahead.
You're kind of stuttering. Is that I'm not the only one seeing that, right?
No, it's happening.
Is my internet connection?
Yeah,
my internet connection is dropping.
Yeah, it's almost you're on the edge. But we have one more demo that Ethan did that is a sort of a knock-on of the last one, and this one shows the oscilloscope in a 2D configuration. So Ethan, if you want to set it up actually and talk about maybe oscilloscope music.
Yeah, or actually I'll set it up after the video. I think that might be better.
All right.
If you don't mind. Can you hear me? Is it stuttering?
Yeah, you stuttered pretty bad.
It's delayed.
Oh, no.
Hear everything you say.
Okay.
All right, playing video.
Okay, so here is a particle effect that is using the left channel, my microphone, for vertical displacement, and is using the bass in the right channel for horizontal displacement. Check. So we should be able to draw cool shapes by doing both at the same time. Yep. Cool. And as long as I keep talking and playing bass, we should be able to keep drawing cool shapes. In fact, I should be able to draw a circle if I sing and play the same pitch. La 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 la. If I were a better singer, maybe that would work. Okay, cool.
It's pretty cool. More bass.
Yeah. Cool. The stutter should be better also, by the way, because I was downloading Total War in the background, so this is better. Cool. So yeah, so we showed off that 2D oscilloscope demo with the bass and the voice and the singing. Yeah, but something that's really cool. It's by someone named Jerobeam Fenderson, I believe is how you pronounce his name. And
Can you say it again? It kind of totally got munged.
Oh, okay. It's Jerobeam Fenderson is the name of a musician. Is this better or cool? And he created an album called Oscilloscope Music, which is actually it's an album of music that is used to actually drive animations and different visuals on an oscilloscope directly. And some people from some tech artists actually sent me some YouTube videos, and Max and Aaron had already knew about it. And so I just set up the emitter there that basically emulates what a CRT monitor would be doing for that oscilloscope, for the oscilloscope music. And actually, if you download that oscilloscope music and actually play it for that Niagara emitter, it creates those visuals. It actually emulates the exact thing that the Niagara, the CRT monitor would be doing. So it's really cool. Yeah, and if I think we do have plans to put out this emitter as an example project. So if you could get your hands on it or build it yourself and download that music.
In fact, the original demo plan was to just
really
show
cool
the
try out.
Yeah, the original plan was to actually just do that last demo with oscilloscope music, but we didn't get permission to play the music yet, and he didn't have any licensing, so we figured we'll just tell you about it, check out his emitter, drop it in, and then check it out. It's extremely compelling.
For sure, yeah. Yeah, and we've got it's more interesting than basic vocal combo for sure.
I don't know. The cool thing about
we've got one more visualization though.
Yeah. So the cool thing about your thing though, before Ethan, sorry, I didn't mean to cut you off. You were.
Oh, you're good. You're good.
You were glitching, but the cool thing about what you did is that and we kind of didn't talk about it, and a lot of people may not know that we have a capability. You are talking directly from a microphone into UE4 and analyzing it live. Like that right there is a huge thing in terms of like, people out there will be interested in making real-time visualizations off of like live music, like live performances. Yeah. And so of course we're interested in that aspect as well at Epic. So it's a huge capability that we shouldn't just gloss over. It's like,
for sure,
microphone input directly into real-time analysis, directly into VFX particle system.
Yeah.
So we have one more demo we want to show.
Using an audio capture component.
Yeah, it's called an audio capture component. We have one more demo. This one was done by Wyeth Johnson, who is a very talented technical VFX artist. This was going to be our sort of highlight at our JDC booth for a kind of a collaboration between VFX and audio, and it showcases a piece of music that we own as Epic because Ethan made it. It's like one of our like demo. He actually wrote it and recorded every part of the music. So I think everybody on the audio engine team is actually a musician at some point. Maybe not everybody, but a lot of us are musicians. So anyways, this is Ethan's song that he didn't have a name for. Or no, you did have a name for it. I named Dan's music, the piano name. This is called Seattle. So
Seattle, okay.
Yeah. Victor.
Pretty good.
So when Wyeth sent that over, I looked at it briefly. I was like, this is perfect, and I didn't realize that it was a very short cut, and I didn't have time last night to ask him for a longer one. But I think it was literally his like sort of hello world, like, hey, it works. But Ethan's song it's interesting to see how it develops for the full thing, but I didn't have time to cut a longer video, so I apologize.
I also sing later on in that, so it's good that we did not get to that point.
Yeah, so Ethan actually has a degree in percussion performance, so that's him playing drums on that live, and you can see his drum set behind him.
Oh, actually, that one specifically, I used a drum machine for a bunch of the drums.
Oh, really? I thought you were playing it live.
It's a combo. It's a combo of things, but those like the kick and snare on that is it's definitely drum
I see.
program. Yeah.
Cool. Well, all right. So I think we're done with our demo and our tech description. This has been a long live stream, so if you're still with us, I appreciate it. But we've had fun. I'm hungry. But I guess can open up to questions if we have time.
Yeah, because we do have a couple of questions. Let's try to go through them, and perhaps I'll just send the rest of them to you, and you can all maybe go on the forum and
Sure.
See if there are any more that you'd be able to address. All right, let's start from the top. Synesthesia is amazing for baked analysis, but what path would you recommend for real-time analysis for something like live visualization during a DJ set?
Well, I think we just showed the Niagara stuff, which is one way. We also have other real-time analyzing capabilities. So actually for Fortnite, for the Marshmello concert, over a year ago now, if you actually Google, if you don't know about this, Google Fortnite and Marshmello live event or whatever, you'll see sort of an in-game event that was done all obviously using native audio engine technology and stuff, but that is actually doing a live FFT analyzer. This is before we got the constant Q stuff in, so it's just a regular FFT, but a lot of the visuals are being driven by live analysis off of a submix. It was sort of an early version of that, but that's been in there for at least a year. So you've got that. We also have live real-time envelope following, which again is before Synesthesia and Phil joined us, where I was just doing a regular amplitude envelope. So not perceptual loudness or anything like that. But we have recently, it's not going to make it out in 425, we've added constant Q to that pipeline so we can get delegates just straight from Blueprint from a submix in a kind of a normal real-time way. We probably should architect that so it comes from Synesthesia so that it's not confusing that the real-time stuff is not part of Synesthesia. But there's other real-time analysis techniques. You can also, when you play an audio component, you can also register to get real-time analysis directly from an audio component, both in terms of envelope following and FFT.
Cool. Let's see here. They were curious if the examples might be available after the stream.
Yeah, we purposely made these all really simple. I think the plan, some of them we could just post, but I think the plan was to make a single sample project at some point and put them all in there so you can just check them all out.
On the Learn tab in the launcher?
I don't know if it probably won't go that route. It's a very slow pipeline to get those out.
Yeah, I think what we'll do is sometime next week I'll collect all of the basic demos from everyone, like Ethan's stuff, into a single project, and then clean it up and zip it up. And just leave out the stuff we can't put in there.
Yeah, and put it on the forum maybe. And then we'll negotiate getting a samples project. It's the problem with the sample project stuff is that we have a really high quality bar in terms of things that need to be done. The samples, it's a separate team that does the samples projects, so it's a little bit harder to get sort of one-off demos that we've made. Like, so Wyeth and Simone are beautiful artists. I'm sure they're beautiful, but they're good artists who can do amazing content. Our stuff, like, it doesn't reach the like sort of visual quality bar, for marketing. And they want their sample project tab and all this stuff. So we're kind of just throwing stuff together to talk about the live stream, and we can share that. It's a whole different thing to negotiate getting something on the Learn tab.
I'll make sure that we put the link on the forum post once it's ready.
That's, by the way, one of the reasons why a lot of this stuff hasn't made it out is that there is a sort of constellation of docs teams, sample projects team, learning. They're all different teams. And so it is somewhat complicated we're trying really hard to navigate that to get resources out to you, people interested in learning how this stuff works. I do want to take a moment to plug we do have courseware that has just launched. Although Dan and I just discovered it seems to have been taken down. We have an email thread going on with the courseware, people going, what happened? And people are having trouble getting the link. There's some weird technical issues going on. But
you just need to log in.
So, but Dan was like logged in.
I logged in this morning to check it, and I couldn't find it.
It literally, I think, is today something happened.
Okay,
but
at the same time,
there is an announcement. It's supposed to be out. Last we heard, I don't know if they decided to take it down without telling. But we contracted out Dave Raybould and Richard Stevens, who are the authors of a book that we recommend people to check out, native audio tech, called Game Audio Implementation. I can't do it right now. I talk, but just Google game audio implementation in UE4, you'll find it. It was made actually and published before I joined Epic 5 years ago, so it is out of date. But the book itself kind of gives you a substrate on sort of. In fact, if you read that book and then start checking out all the new audio stuff, you can see the sort of starting point where after I joined the team and where we're evolving from. But it's still relevant because a lot of concepts are similar, and most of it is still backwards compatible. Although that might change rapidly now that the audio mixer is on by default. But because we were so impressed with their work, we contracted them to like do a whole courseware for us. So it's the same people who did that, and they're now officially part of the sort of Epic team, audio engine team, and we work directly with them. We have Slack channels where we're collaborating, we're telling them features, they ask questions, so we're sort of working with them, and it's the official sort of pathway, and I highly recommend it. We'll hopefully get it back up and running soon.
Awesome. We had a question, I think, earlier related to the convolution reverb. If the IRs are stereo, are you upmixing to rear channels for surround configs?
I'll let someone else answer if you want.
Yeah, Max could probably explain it exactly a little better. But yes, that's right. Right now, it's just a stereo. We're down mixing stereo. That's going into the reverb, boop, coming out, and then we have an up mix for stereo bleed. And you have in the settings, you can actually control how that bleed works, whether it's inverted like flipped surround, or if it retains its left-right orientation.
That said, though, we do have the capabilities of doing true multi-channel impulse responses. We just haven't implemented it yet, but we have a plan for that. And we actually want to go out and get some of our own multi-channel impulse responses and environments and stuff. Like there's nothing that prevents it other than just more CPU costs. It's more convolution.
Yeah, we've talked a lot about different approaches we might take to like surround multiple mono, or if it's like actually a surround convolution impulse, or also implementing true stereo impulses, which is also something we've talked about in the future. So it's exciting.
Great. Let's see, this user's little general question. Where should I start if I want to write an audio plugin? I've written some VSTs in Juice, but I have no experience coding in Unreal Engine. Do you have any DSP examples available?
Sure, I can answer that. So check out my GDC 2017 talk. I actually do a live stage demo where I use one of our code gen. I made like a sort of wizard. It's not easily discoverable. It's not like click a button and then make a plugin, but I demo it live on stage then, and I think it should still be working. And if not, you can figure it out by looking at some code note, which I'll explain in a second. But then I demoed basically creating a synthesizer live on stage. It recompiles it, it hot links it. That's all real, by the way. Other engine programmers were like, Aaron, you're nuts. What are you doing? Like, depending on the hot loader on live on stage. And I was like, I don't know, go big or go home. So that was all live and it worked, which is exciting. But that basically is a Hello World synthesizer. It's a sine tone that changes pitch and stuff. And I created a blueprint around it so that when it compiled, it would just like slot right in. But what I would check out is the Synthesis plugin. If you're a programmer, just like download the source, search it for Synthesis. It's like Synthesis and DSP, and you'll see a whole bunch of effects. We have source effects, submix effects, a bunch of synthesizers. There's some, I would recommend starting with source effects because it's sort of simpler. And check out maybe the ring modulator effect. It's very short amount of code. It's like 50 lines of code. It's very, very simple. It's an exciting effect to start with because it's very simple to implement and it sounds really cool. I think it's a great sort of hello world of writing an audio effect. And of course, for a synthesizer, we've got a whole bunch of different synths that you can implement. And then submix effects, you have to deal with multi-channel output audio. I've intentionally restricted source effects to mono and stereo, although we can play multi-channel sources. The source effects are restricted to mono and stereo, intentionally to keep it simple. That might change in the future. We're tending towards greater complexity as we get towards more flexibility, but right now it's pretty simple to just start doing source effects in mono and stereo. But submixes are cool because then you can start implementing and researching reverbs and multi-channel surround. You could build a whole audio engine from scratch, or if you're using a middleware engine and you're interested in figuring out a way to plug the two together, submix effect might be a way to go, where you implement the entire output of a whole separate audio engine as a submix effect. You could do that, or vice versa. If you wanted to make a plugin of UE4 inside of another audio engine, you could also do that. So anyways, I would recommend that as a way to start checking out our DSP and plugin API. We are growing a very robust DSP library. All the stuff that we're adding, the convolution, all this stuff is put into a API. Signal processing module, I think, is where it's all going. And it's becoming very robust, and it's all there available. You can check it out, learn from it, find our bugs, let us know.
Awesome. Does Synesthesia support OSC natively?
So the Unreal Engine supports. Sorry, I'm jumping on all these questions. I'm just used to getting asked questions from all directions at all times. So I just like, boom, next one. So OSC is actually a plugin that we have implemented. Rob Gay on our team is the person who we actually contracted someone to kind of start it, and then Rob kind of finished it and got it over the finish line. But we have a native plugin that is just full OSC support. For people who don't know what that means, it's called Open Sound Control. And actually, Ethan and I both worked with the guy who developed it, Matt Wright. He was my professor at. Oh, also Phil. I forgot. That's right. So both Ethan, Phil, and I all worked with the person who developed Open Sound Control.
Shout out to Matt.
Yeah, which is kind of crazy. So down in UC Santa Barbara, Media Arts and Technology, Matt Wright was a professor there, and then later he went to Stanford, which is where Ethan went. So it's kind of funny. There's a weird connection. So we all love Open Sound Control. It, in a nutshell, it is a MIDI like. It's kind of like MIDI, but more generalized. It's a standard network protocol where the intention is for hardware and other arbitrary things to route control data around. But it's grown. It's really flexible. You can actually route audio. It could be an audio streaming API. You can do all kinds of stuff. There's a bunch of third-party apps that let you build interfaces. Like a Touch OSC is a really cool thing that a lot of people use. You could like build a really cool interface on your iPad with sliders and 2D things, and then directly control Blueprint. That's sort of what we use to test and validate that the OSC is working. One of our, so every year we do keynotes at GDC. So we haven't announced what that is yet. It's very exciting from an audio perspective. I can't talk about it directly, but I'll just talk about the tech. One of the things that we were going to demo was controlling the audio engine live from Open Sound Control from an iPad in the audience wirelessly. Because from our experience in 2019's GDC keynote, which you can go and check out, there was the Chaos physics announcement. So Dan did all the audio in that project. Well, he was there were some contractors that worked with him on it, but we discovered painfully that mixing a game for a game is a very different experience than mixing a game for a theater demo. And so we didn't have the tech sort of built to do live mixing with a cooked build. So we were literally last year, like sitting there coming up with and getting feedback from like the directors and stuff on the mix, and then going back, tweaking some parameters, doing like a 4-hour cook. And then coming back and listening to it, and we're like, oh my God, this is the worst workflow ever. And so we're like, we got this Open Sound Control plugin. We've got MIDI control, sliders, all this kind of stuff. So we actually implemented tech that lets us control that stuff live. And then we're going to use it as a booth, a GDC booth demo to like hook it up to a fader port and show a live cooked game where we have everything mapped and can control the mix dynamically. But the intention was to control that so that we could sit in the audience and make sure that it works great, and then just save the mix configuration. And all of that was going to be done with Open Sound Control and some other features to allow dynamic mixing. We have a new feature, which we haven't talked about, that was also implemented by Rob Gay, called audio parameter modulation, which we also used in this GDC 2020 keynote that I can't talk about. But that was going to be another thing that we were going to demo hooked up to this OSC controller.
That was.
I'm talking about the
solid
tech. I
answer.
didn't talk about the demo itself. I just talked about the tech. We obviously have audio.
Coming soon, TM.
Yeah.
Are there plans in the roadmap to develop a native HRTF headphone render, or are we still relying on Oculus and Resonance?
I could probably answer that
Yeah.
for now, at least.
Yep.
So,
Oh, maybe you can't.
I think we've talked about it. We talked a lot in the past about like kind of trying to develop our own native HRTF renderer because it'd be nice to have. Oh yeah, maybe I can't because of my connection. But
Yeah, no, we can hear you now, but
okay. Yeah. If anything drops, just pretend it was something smart that I was saying. But yeah, previously I've worked on HRTF renders at Dolby, and I was working at PlayStation supporting Audio 3D there. But we made an ITD spatializer specifically, which is super simple. It doesn't do any filtering whatsoever. It just emulates the delay between the left and right ears when a sound is over here, which is really good cue for localization of sound.
So
Sorry,
ITD stands for interaural time delay. And technically it is a binaural renderer, but we actually, it's a native binaural render. It just doesn't apply the filter in convolution. But we use that as a sort of plug-in agnostic, like something that we own to test the sort of API flow, the sort of signal flow. But we have the talent on the Audio Engine team to write a HRTF renderer. I think the question is strategically, is it really worth doing? Is there anything that we can contribute? It's like the one space where there's a million third-party plugins and companies offering solutions. So why would, what are we going to do better than them? I don't know.
One other thing that's been really nice is recently Google Resonance actually has been open sourced and is publicly available on GitHub. Yep. So we've actually been able to take the code from Resonance. If you've been keeping track of code changes to the Resonance plugin itself, you may notice that we actually compile the code for Resonance via UBT directly. So if we ever want to extend or implement or use anything with Resonance's code base, and perhaps extend the feature set, perhaps swap out the HRIR set it uses, the HRTF set, the set of ear measurements, essentially, we can do that.
We've actually recommended. Sorry, I keep cutting you off, Ethan. Sorry, but we've actually recommended it to third-party HRTF sort of companies that have some like unique thing. I won't say who they are, but they'll be like, "Hey, we have this really cool thing. It's not the renderer; it's this other aspect. Something." And we're like, "Well, we don't have a renderer, but we have Google Resonance open source. If you augmented their renderer with your tech, it would be very easy for people to integrate it." And companies have gone and done that. So it is, if you are listening and you're a researcher in spatial audio and you're interested in some unique aspect, I recommend checking out the Google Resonance API. So it's very easy and simple to add. And the other thing I'll point out to that is that Fortnite launched 6 months ago with a 3D audio feature. And that actually is Google Resonance. So Google Resonance now is probably the most widely, as a result, the most widely used HRTF renderer in the world. And it is extremely battle hardened because there's a lot of reasons why we chose that over other solutions. Briefly, it's inexpensive because it has a couple of optimizations and tricks it does. 2, it's open source, so we have the source and we can fix bugs, and there were plenty. There are still some bugs that we need to fix, but when it first launched, we had to go through the code and fix a bunch of stuff. And then 3, it works the same across all platforms. So the experience of our players won't be different, which is a really important thing for a game that's competitive, right? So if you're going to do a binaural solution, if it sounds different on PC than on a console or whatever, then it'll be a very strange experience for players. So Resonance kind of checked all the boxes for why it was a good solution for Fortnite. But
gonna do 2 more questions and then we need to wrap up because I think Aaron needs to eat. I need to use the restroom, and we're getting pretty long now. Does the convolution reverb work in dynamic environments, for example, like Chaos Destruction?
So I think the implication of that question is that the convolution reverb is doing some kind of ray tracing.
Mm-hmm.
It's absolutely not. It's like, think of it as a normal parametric reverb where you're like, here's my settings. I think I saw in the thread somebody was asking, like, can I dynamically create an impulse response off of a scene that I built in UE4? You can't do that now. There's nothing like any programmer will say nothing's impossible. We could totally do that. But right now the feature doesn't support that. So the answer in a weird way is yes, it works in dynamic environments, but no, it won't automatically respond and build an impulse response that changes based off the, but you could hook that up. You could write some code that's like, oh, my building got destroyed. So stop playing the like building or reverb, like crossfade to impulse response that I've tuned as a sound designer to sound more open or whatever.
Any plans to implement LUFS and or RMS/peak metering?
Phil?
Yeah. Yep. So the loudness analyzer is, I don't know, that's like 3/4 of the way there. It's got all the tech in it to do that. It's just kind of matching the standard of what those metering techniques are and then exposing it in some convenient way so people can look at the values and do what they need to do to fix it.
Basically, we have a vision of creating a part of what Synesthesia was intended to build towards is sort of a suite of audio profiling and analysis tools. So we want to use it to add capabilities for real-time analysis to the submix graph or debug displays or a standalone tool that allows you, like if you're familiar with Solfa on PlayStation, sort of doing real-time analysis in a standalone tool so that you can look at your audio output from console or mobile, like live on your PC. So that's the direction that we want to take Synesthesia, and Synesthesia will probably become this sort of tool for all this stuff. And obviously LUFS, LKFS is going to be part of that. So as you play your game, you'll be able to see the graph on what your LFS and LKFS is. So one important thing, a lot of people probably have no idea what that is. So I'll just briefly explain. What that is a sort of standard loudness metric that uses perceptual loudness like Phil's talking about. The primary difference between perceptual loudness and LKFS and LUFS, I forget what those letters stand for, by the way, just look it up on Google. But the
loudness unit full scale.
Yeah, okay, loudness unit. Anyways, the difference between those LKFS and LUFS are broadcast-based standards, whilst what Phil was working on was perceptual loudness as for the application domain of visualization, which means it's like super tight. It's like what the loudness is at this exact moment in time, whilst LKFS and LUFS do more sort of temporal analysis. So you can say like this commercial is at this LUFS, and you can just label the whole commercial as at this, right? And its whole point is to like sort of create a broadcast standard, so you're not at home listening to your TV show and then the commercials come on and your ears get blown off, right? So they're like, no, everything is like this. And video games are, I in my opinion, have been sort of lagging broadcast standards on loudness standards in this regard. I'm of two minds where that's a good thing and a bad thing. I think the use case for broadcast is like you experience lots of media in short bursts. And so it kind of makes sense that those things need to be sort of standardized. But video games, you load up a video game and you play it for 12 hours. Who gives a shit? Oh, sorry, I shouldn't swear, but who cares if your loudness, is different than the next game you play? Like I feel like this, it should be up to the aesthetic of that game to decide what their loudness measurements are, and they should be able to expose to the users how they want to experience their loudness. So you go to preference. So like I'm playing my video game, I don't want to wear headphones, but I got a kid sleeping in the other room, so let's make my loudness dynamic range really tight, and then so I can, things like that. So it's all configurable. So I think it's probably not a bad thing that video games don't have a broadcast standard, but I could talk for hours about it. But anyways, the answer is yes, we want to do it.
Quick caveat is that it is kind of useful for some platforms and stores do require, as part of their certification process, to target a specific LUFS level.
So part of cert for like consoles specifically have that. The problem is that it's pretty loose. I've seen them, and it's like what is it like? Also in a video game, it's so like you're sitting on the front end, and then you go play a combat, and then you come back, and all of them are temporal. So they're like, it needs to be this for a certain amount of time, like in 10 minutes, it needs to be. But like, how is that even being done? Like, who decides what part of the game they're playing at? I don't know. It's interactive, so like, the player could go and sit in a corner where nothing's happening for 20 minutes, and your LUFS is like really low, and then go play combat for 20 minutes, it'll be really high. So it's like almost impossible to really get a good metric on it.
Yeah. If that 6 plate on the table, then we would have went over the LUFS from the collisions and stuff.
Exactly.
Yeah, stuff like that for sure.
All right, that was 2 hours and 15 minutes on the mark.
Wow.
I appreciate all staying around for so long, answering a couple questions. For everyone who didn't get the questions answered, I will be following up with the audio team, making sure that they have all the questions, and hopefully they can maybe find a little bit of time to answer them on the forum announcement thread, which is on the event section of the UE forums. And I think with that said, I want to thank everyone for coming on. It's been a pleasure. A lot of nerd talk, which I think why we're all here, why we're all doing this. So I'm very happy about that. And I'm going to skip my normal outro spiel because we are out of time. But I do want to say that next week we will have Richard Hinckley on the stream talking about iterative design for comfort, essentially how to use Unreal Engine and the tools within it to design so that it's comfortable to work in. It's an interesting concept, so I hope to see you all there. Any last word from?
I want to say, Victor,
of course,
thank you
Aaron.
so much for having us on here. I really appreciate that you invited us. This is a huge opportunity for the Audio Engine team. Since we didn't have our booth or anything at GDC, this was a great outlet for us to talk about our tech. So I really appreciate it.
Happy. I'm a musician myself, so you guys know that you're some of my favorites on the stream. So anytime. All right, with that said, I hope everyone out there has had a good time watching, and we will see you all back again next week, Thursday, same time. Bye, everyone.